Thank you so much for waiting. I believe we'll start with the session today. So a very warm welcome to all the attendees of this session. Today, the webinar that we are hosting is titled Reimagining Engineering Learning for India. I would like to also thank our distinguished panelists and to give a brief introduction about them. First and foremost, a distinguished professor, Dr. Krishnan. He comes from IIT Madras and has a long and distinguished career teaching the learners and building the future of this country. Mr. Ravi Bhushan Singh also has a very long career with Schneider Electric, a very big proponent and supporter of NAMTECH as well. Plus, he's worked a lot in the area of industry, especially in Schneider. Mr. Arunkumar Pillai, who is the Director General of New Age Makers Institute of Technology, NAMTECH, and last but not the least, our moderator today, Mr. Narayanan Ramaswamy. He is a national lead at KPMG India for education and skills. Nana, I would request you to please take over from here. Thank you so much.
Thank you, Rajiv. Thank you so much. Good evening to everyone who's joined this very interesting and very important call, a webinar. And what we are going to do in the next few minutes is going to be some breezy discussion. And I'm really fortunate to have a panel which has got some fantastic representation. Imagine one from a leading industry, one from one of the leading existing educational institutions, and one from an institute that is making a big difference in the connect between industry and academia. So wonderful. With that, I thought I'll start by sharing some of my thoughts as to why this topic and why it is relevant to have this now. Right? If you notice, never before has manufacturing been in the center of our GDP growth in the past history. We are looking at achieving the $30 trillion economy by 2047, and we want to be the third largest economy. All these things cannot happen without manufacturing playing a very vital role. Today, we are talking about roughly 70 to 18% of India's GDP coming from manufacturing. And it is all set, according to even national manufacturing policy, to contribute to 25% of the GDP in the next 2 years. Not just that, it's also going to create, according to our estimate, more than 100 million additional jobs. What makes it even more interesting, if you go by 2022 statistics, India's merchandise exports hit a remarkable $400+ billion. And this is a great achievement and underscores the sector's potential to generate foreign reserve, trade balances, and all the rest of it. All of this indicate that there is going to be more FDI flow, there is going to be more industries, there are going to be more and more people employed in this, making it such an important part of our growth journey as well. So for all the youngsters in the call, this is going to be a sector that is potentially going to make a huge difference to your careers. And hence, I guess it is very important to look at manufacturing. Now, what is happening in manufacturing is very interesting. We've all heard about this term Industry 4.0, which essentially means the digital technologies that has come in. Some of them, affecting the sector more, some of them less, some of them promising to have a lot more changes. They have done some interesting stuff to the industry, particularly some aspects of manufacturing industry. They've created a lot of newer job roles, unless what is going around, it's not as if they've taken jobs. Of course, there are some modifications in the jobs, but they also created a lot of newer job roles. Like, you will soon hear terms like, human machine teaming managers, autonomous remote plant operators, digital twin engineers, smart QA manager, sustainable manufacturing specialist, additive manufacturing engineers, many such things, and I can go on. And at the moment, artificial intelligence and machine learning seems to be doing a lot of change, but also soon we are going to have a lot more of this playing a role. In short, Industry 4.0 is changing the role of what a professional could play in the sector. And I suspect reskilling and upskilling is going to also play a major role, because it's not as if, suddenly you can let them in. The existing people also need that kind of changes happening. So Industry 4.0 is making us relook at the sector. Maybe it's a leveler for an economy like India to look at manufacturing in a manner where we don't have a baggage of the previous manufacturing techniques and plans. So I would see it positively as the advent of Industry 4.0 giving us a lot more additional edge as a country and as a geography to play our role in the manufacturing sector. Lord, but not the least, the third dimension that we are looking at it is our educational institutions, our current institutions, how much are they geared for leveraging this opportunity? Our youngsters who are part of these institutions, their education that they are going through right now, or be it universities or skill development institutions, in whichever format you take, are we really geared for doing this, right? And that's why I said there are three eminent panelists, each one looking at these different aspects of it. My role becomes so much more easier as I invite them to share their views. But what we are going to hear is how do we solve this conundrum? There is big opportunity and there are promises there. Are we geared for doing this? And what should we do to make sure we leverage this? To discuss this, it is with a lot of pleasure that I'm going to invite Mr. Ravi Bhushan. Ravi, you've been a pioneer of not just in your industry, but also a big ambassador of the changes that you want to make in the training, education, and related areas. I was always curious, what is your expectation from youth, from those who are in the call and beyond, in terms of what are the skills and competencies that you are expecting in the job roles that you give for them? Also, what has changed in the sector in terms of requirements, like past 2 years to now, in future, what's changing? And a third question in that, I'm sure you have your learning and development and training programs and others in your upskilling program. Do you see a change in that? How are you handling this change in your sector and in manufacturing at large?
Thank you, Nana, and good evening to all of you. A very serious topic to discuss on a Friday evening. But I think it's a very, very fundamental question that is becoming more and more intense and more important as we are sharing one of the largest population of young people in India. If we don't skill them and we don't skill them correctly, we will have a lot of young people jobless and not be able to address their needs and aspirations in life. So I think from an industry point of view, Schneider Electric has more than around 28 manufacturing plants in India. And while we provide solutions and technology for other industries, we ourselves are a manufacturing intensive company. So we have many, many manufacturing units. And for our own manufacturing units, we have observed that the need for skilled manpower has changed in 1 decade. Historically, the typical type of job roles that we were looking at is somebody that would understand how a motor starter would operate and how essentially a drive would function and how a PLC would be programmed. And then let's say that understanding a SCADA would be the top layer of the skill set. But if you look today, even in our manufacturing units, there is a strong integration of information technology that is happening together with the operational technology. Yeah. And this information technology is creating new types of roles and responsibilities in our manufacturing plants. Now, if you look at a manufacturing plant, it is not only about the industrial process that we are talking about. There is a strong integration with the energy infrastructure that comes into supporting the production or the manufacturing that is going on. So even in the area of the energy infrastructure, there is a strong integration of operational technology, so hardware in sync with the information technology. Now, if you look at the kind of students that we get from the market when we employ are mostly very good either in electrical or in maybe PLC programming coming from electronics or information telecommunication backgrounds, or maybe only very good from the IT or software point of view coming from information science and computer science. But I believe that today the kind of job roles that we have requires an integration, a multidisciplinary skill set combining both the knowledge of hardware and as well as of software. Now, this is not changed into our curriculum, and I'm waiting to hear from Krishnan about his views on it. But of course, there are a good bunch of institutions that have evolved, have really understood these challenges of skills that are required in the market, and they are addressing that curriculum. But by large, I think these are still some of the issues that we are able to see. Our education system suffers for two types of problems. One, of course, mostly it was conceptual learning. There was not too much of exposure. I am myself an electrical engineer, and we faced this when I studied. Not too much of practical exposure to applied learning or project-based learning. And then the second issue that we are facing is that there is a strong disruption in technology that is happening with the whole IT-OT integration that is taking place. So our education system has to cope with both of these elements, wherein we move to a more practical based approach of methodology of learning, and at the same time adopt these new skills and new technologies that are coming. Now, because of the new skills and technologies, I think, companies like ours invest strongly today in upskilling. If we don't upskill our own employees, it is a big problem. And of course, we invest as a company strongly into our own learning and development and training for our employees. And it is true that skilling is, it's a never ending process. Every time, we have to, even today, we are upskilling ourselves. And that's not a problem for a company to invest. But there is a strong ecosystem that exists, in the name of institutions today in our country. It's a massive infrastructure. But this massive infrastructure is not shifting to address the challenges of upskilling that is required. And these are, some of the views that I probably have. And with that, probably I will just add some of the skills that we feel, are new in the industry. Of course, everybody understands that we require PLC programmers, we required somebody to understand drives and how to be able to connect motor starter, etc. But if you look from those roles today, the kind of roles that even our factory looks at is data scientists, IoT engineers, smart factory managers, people with the strong abilities of robotic engineers and technicians. Then even in terms of smart factory supervision, smart QA managers, cybersecurity professionals, it is misunderstood that cybersecurity is only a question of IT today. It's also a strong question of OT today, because the IT is integrating with OT. So OT, cybersecurity professional, these are roles that are strongly demanded in industry today. Now, since any industry or manufacturing unit, when it works, it needs to be complemented by the energy infrastructure. So that we see that because of this whole digital integration that is happening to hardware, even in the space of energy, there are roles like sustainability specialist, energy analyst, etc., that are coming into this space. Now, these are skills which, according to us, is not at a very large mass level are being adopted at the institutions, and the students that we look for do not have these skill set immediately. So in our consideration, it is definitely something that we consider as a challenge and must be addressed for sure. With that, I will finish my marks here.
Very interesting. Absolutely interesting. And the way you shared your thoughts, there seems to be more and more exciting in terms of the future for some of the professionals who are looking forward to this industry. With that, let me turn to Dr. Krishnan. Professor, you obviously have been a seasoned academic. You've seen the Indian higher education sector from different angles. And of course, you are the distinguished professor in IIT Madras. With your background, and also from your interactions and experience with the industry, where do you see the gap? Ravi clearly said that, maybe right from our times till now, the education institutions are perhaps not fully catering. Do you agree with that? If you think so, where is the problem? Not just from IITs, but in general, the larger engineering and technical education perspective, where do you see the gap, and what in your view could be done, or how do you take this forward? Professor,
Nana, I hope I'm audible now. Thank you so much, Nana, for this. And thank you for NAMTECH for giving me this opportunity to interact with some of the best and young minds of India. Just wanted to start by reacting to your question. What we must go back and try to understand what is really manufacturing and look at it from a more holistic point of view. Now, conventionally, if you look at manufacturing, everybody associates manufacturing with a mechanical form of manufacturing. And another problem that you normally associate with manufacturing is the male domination, where very few females are, sort of participating. Now, if you really look at, is that what manufacturing is all about? Is manufacturing, shop floor operations? Are you talking of, say, lathe operations, milling, forming, grinding? Is that what manufacturing is all about? And if you look at what's happening globally over the last maybe 20, 25 years, you'll see that these are very, very small part of manufacturing. However, if you look at our curriculum, you find that this is not depicted, that the change has not come into picture in the curriculum, particularly when you talk about manufacturing. Today, if you look at manufacturing, manufacturing is more automation centric. If you go to, a car manufacturing plant today, you'll find that most of the manufacturing is done by robots. And the people who are involved are usually controlling these and writing the software, looking at how to optimize the manufacturing process. And very few of them are looking at it from a conventional point of view. Today, of course, with additive manufacturing and 3D printing, you would find that that paradigm is even more shifting away from such, conventional thinking. Another point which must also understand in terms of manufacturing is that manufacturing is not all about, making mechanical parts. If you look at manufacturing, you've got to broaden the horizon, whether it's electronics manufacturing, whether it is petrochemical, manufacturing, whether it is fertilizers, or whether it is even manufacturing very large infrastructure. All of it are also manufacturing processes, maybe of slightly different flavor, but they're all also manufacturing. So the narrow point of view that we have on manufacturing is the first mindset that absolutely needs to change. Now, today's industry, and I think already my Ravi has mentioned a lot about what are the expectations. The expectations today from engineer is very different, particularly if you're talking to manufacturing, compared to what it was, say, 30, 40 years when many of us or some of us went to school. Now, when I went to college, and the first thing that you learn in the first year is that you wear your khakis, and then you go to the workshop, central workshop, and then you start, learn in lathe, you learn milling, you learn forming, you learn casting. That was an essential part of the curriculum. Now, interestingly, in 40 years, that has not changed. Even today, even in some of the best IIT institutions, you'll find that a bachelor person, the first year, they learn all these things. And then they learn the theory behind all this. Now, if I were to look back and see, have I ever touched a lathe or a milling machine since I graduated 40 years ago? The answer is no. And that's probably the same answer that many of us other students are probably going to experience. So the point is that today engineers must be trained differently. They must be trained on the new age technologies that actually they can put to use when they go and find a job. And that is a gap that needs to be filled. Today, if you ask me, what are essential tools that the students must learn, you're talking of 3D printing and additive manufacturing. They not only need to understand the different technologies and the different theory behind that, but they must also understand hands-on how to program and get something done using additive manufacturing tools. They must learn sensors, controls, IoT, Internet of Things. Now today, more and more, and it was interestingly already mentioned by my previous predecessor speaker, Ravi, that today we are talking of digital twinning. Just this afternoon, I was talking to somebody who says, the guy works for Epic, and he told me that an entire new city in Saudi Arabia is a digital twin. A complete version of that exists in both physical form and functional form. Digital twins are becoming a very important part of the way manufacturing is done today. Of course, then you throw in the AI, you throw in the robotics. you are actually talking of very different types of training and very different types of pedagogy than what is today. Even today, in the best institution in India, these are hardly ever thought as are being considered as necessary, to teach. So they must not only teach the theory, but give an opportunity for the students to go and think and try to solve problems using these technologies. It should not be just something that's prescribed like a lab experiment. You go, there's a prescription, you do exactly what you are told to do. You get some results and you write a report. And I think there must be a little bit more training there where problem solving becomes a part of the curriculum. And that's again another addition that is necessary for somebody to be employable. I mean, today, I think already, again, Ravi, you had mentioned it, more and more software-defined manufacturing is going to be very important. I'll give an example. There's a course called DOX or DOF, okay, which means Design for X. Design for Manufacturing is a course that we teach, but we don't teach it to the undergraduates. We teach it only to the graduate students. So this is an interesting paradigm where we believe that Design for Manufacturing is not an undergraduate curriculum, but I think today the industry wants it to be an undergraduate program. So that is the first part of my reaction to the question. The second question is on employability, right? And again, I think Ravi and the industry can actually articulate it a lot better than I can. But if I look at it, I mean, even 20, 30 years ago, when I was in the US, I used to hear this every time. Every time I talk industry, he says, you guys are putting out products, but they are not employable. We have to completely retrain them, and then they become employable. Now, there are two issues to this. The first and foremost thing is, I don't think the industry's expectations are absolutely valid. It is not possible to train or any program to train people for a particular industry. Okay, so if an industry wants certain skill sets, then they have to retrain them or super train them if necessary. However, it is important to make sure that the students coming out of undergraduate programs have the ability to be retrained, wherein all the new technology that I'm talking about needs to be inculcated into them. However, they may super specialize in one or two of these and then become more useful for the industry. So that is the first thing. The expectations have to be more moderated. However, if you look at from an academic point of view and say, are we doing the right thing? And more so from an Indian perspective, we see that maybe only 50% of the students are employable as per the industry. And that too after a lot of retraining. The reason is very simple. In India, we probably put out about 1.5 million students every year with an engineering degree. And if you look at what are the kind of training that they get, except for the top maybe 20%, 30% of the institutions, the rest of the institutions are not well equipped. They don't have the necessary faculty. They don't have the necessary infrastructure. And absolutely, even the, as I mentioned, even the best schools do not have the, the new age smart manufacturing, kinds of courses or faculty who are equipped to teach these courses. That is very limited in our country. So essentially what's happening today is that more than 50% of institutions are not equipped to put out qualified students, even with, irrespective of what the curriculum is. And then we move to the other 50%, where we believe that high quality institutions and facilities are available. But then if you look at it, even you look at my own institution, in the last few years, even essential programs, and these were again re-emphasized by Ravi, very essential outward-facing programs like industry internships, final year projects for BTechs, all of them have been removed. So today, I have students who have never done an internship, never seen an industry, or seen the door of an industry, never done anything which amounts to a final year project. graduating on a regular, consistent basis. And the reasons why behind that are many, and these are not the not the lower 50%. They are the higher 50% institutions. In fact, the top 10% institutions are also now removing the industry-facing components that was actually initially considered important. Today, students prefer to do internships in startups, which are mostly soft-oriented. They prefer to do in research labs, in India or abroad. Very few actually want to go to industry and do internships, and that's a very sad situation today. So again, when I'm talking of some of the top students coming from the top institutions, again you see the same thing. They're not well equipped, to deal with the expectation that the industry is imposing on them. So, I mean, these are just a few of the issues that actually need to be looked into carefully, and we need to find better mechanisms over the period of time. So I think there is a significant room for relooking at how we train, how we educate, how we upskill students and make them industry ready. So I hope we'll have a better discussion when we open up the floor. Thank you.
Thank you, Professor. Thank you so much. Absolutely pertinent thoughts, and you put it out so very nicely. And coming from the academic fraternity, you're frank in discussing what is happening there. And I particularly like some of those things that you said about the male view of an engineer and how there is an ancient view of how the engineering shop floor would look like, and a big shop that people have when they actually come to the Gemba in the industry to see that these are things that perhaps are should be in a museum and not in an education industry. Now, this is very interesting, and some of your thoughts I'll come back to you a little later. Now I'll turn to Arun. Arun, you have a very interesting career. You've been on one side of the table, as they say, part of the industry, making things happen, a dashing entrepreneur, then part of a large industry, consulting. Now you are leading an institution that is looking very different from the looks of it. And I know in our association, we realize this is absolutely the new age institution that we are looking at. You heard both sides, right? What is NAMTECH doing differently? How do you think that we can bridge this gap that Professor very nicely articulated? And Ravi earlier alluded as to what is the expectation from industry. And also remember, he said he's spending a lot on reskilling, upskilling his existing employees. So it's like, there is on both sides, here is a supply, which perhaps is not catering to what is required. And there is a huge demand on one side that has certain expectations. Where do you think your institution and your format is playing a role? And how do you think this gap can be bridged?
Thanks, Nana. And thanks, Ravi and Dr. Krishnan. Dr. Krishnan, thanks for your very frank views, and Ravi for what you're seeing on the industry side of it. I think we all agree there is a gap, and we all agree that this gap is also growing. Big thanks to Industry 4.0, sustainability, and various things. But then we also must understand from what is happening in this sector. From a government's perspective, I think the government is trying to do certain things. If you look at the new education policy 2020, the government has called for, rather it is made certain things, regulatory norms, much more liberal in terms of the system being more multidisciplinary, modular, multiple exit, entry, and various formats. So the policy environment is there. So it is like, it is not that the regulatory environment is stopping somebody from relooking or reimagining the engineering education. Then it is up for the institutions to step up. Now, some of the institutions are doing it. Some, of course, because of various legacy, it becomes a very big challenge to, they're big tankers, it's very difficult to change direction. So it will take more time. So maybe it's the time for looking at some kind of new set of institutions which could actually accelerate this whole process of reimagining this engineering education space. This gap which Dr. Krishnan and Ravi spoke of, I would break it up as not a single, not a monolithic gap, but as 5 gaps. First and foremost, when I look at our students, there is a huge awareness gap. Students do not know what's happening in the industry, and students do not know are unable to relate to when they go to industry. It's something new for them. So the huge awareness gap. The second piece is while you say skill gap, but I think there is a huge knowledge gap, skill gap, and an attitude gap. All the three gaps exist. And the last gap is the fact that since students do not make anything of their own, there is a whole imagination gap. So we are talking of five gaps, like awareness gap, a knowledge gap, a skill gap, an attitude gap, and an imagination gap, and not purely a skill gap. So this kind of gap, if this has to be bridged, a whole lot of work has to happen on the engineering education side. And this is something we have been thinking of at NAMTECH. We are thinking, how do we do this? And the way we look at it is that you can only address the awareness gap by bringing the industry into the workplace in some format. And that is what we call as introducing the student to the application side of it in the beginning. It's not that we introduce students to the various theory subjects in the beginning, but we start with introducing the student to the application. So when we say mechanical engineering, or when we say any of these kind of multidisciplinary engineering areas, which Ravi's manufacturing itself multidisciplinary, being multidisciplinary, we start with either a product or a system, say a car or say a smart factory. So we introduce the student to those kind of things, and that hopefully gives the student a big picture of what he's getting into. And that's the first set of first gap we need to bridge, so that a degree of awareness develops that this is in manufacturing, this is engineering, and this is the beauty of it, and this is where I would love to spend my career. And once you have created that interest in the student, then we say, let's break that what you just saw as a system or a product, let's break it into elements. So say you saw robotics, a robo, and then you say that, well, what is it? Does it have what automation elements, hydraulics, pneumatics, electronics? So that begins where we get into starting addressing the knowledge, the skill, and the attitude gaps in that piece of it. So now that the student has understood the bigger picture, understand what goes into those components, we move to filling the last gap, where we tell the student, now you need to design and make it yourself. And that's where it calls for somebody to be innovative, imaginative. Student has to now actually take stock of what does he do with it, or what is the real life solution in the industry he or she has to solve. So when we address this, then I think in a sense we address the complete gap between what industry is seeking and what we are producing today in engineers. And so at NAMTECH, we are trying to create programs which act in this fashion. So therefore, the infrastructure is also geared in that fashion. If you come to NAMTECH, you will see that much of the initial introduction to infrastructure is the application side of it. We have smart factories, we have cars exploded, we have robots in various application environment, we have a smart energy environment. Once that is, in a sense, the students pick up this, then we move them into their learning elements. And finally, there's a huge maker space, where they make things, design things, and make things, or they go into the factory or into a plant, a capstone project, where they actually design and make things. So in a sense, this is how the curriculum is developed, built backwards, starting from the industry side of it, and then bringing it to a case where the students do it themselves. Now, how do we deliver it? Well, we are now also, the other big dimension is how do we use digital while delivering it? While physical is a common thing, face-to-face, we offer various things, programs, but sooner or later, everybody knows that digital becomes a big component. Not only it is not about teaching being digital, but the fact that students are all comfortable learning in a digital format. So how do we blend the physical and the digital while delivering this program? Each one of these modules which we talk, whether it is on the application side or the learning side or the make or design side, have clear elements of what we call as phygital. So there is there's a physical, of course, and then like what Professor spoke or Ravi spoke or digital twins, we are talking of digital twinning in education itself. We simulate an actual smart factory in a digital format, so students can actually create various kind of simulations can be done done while keep offering the program itself. So in a sense, this is what we talk of when we say that kind of a new age program, which is very industry aligned, which seeks to create real engineers who solve real world problems. Um, the programs which we talk again, like the professor said, we have the undergrad program, which is a 4-year program. At NAMTECH, what we do is we work at the postgraduate level. These engineers who come out, we put them through this set of this kind of program, 1-year program, and eventually we create engineers who would be really who would in fact drive transformation in the companies in which they are going into. So and the second time, this is about the pedagogy, the curriculum, which we think is the new age and which should help create this change we are talking. And it has been well received by both traditional industries and also new age industries. When I say traditional, the biggest traditional industry in this country is auto. And when I say new age, the new ones like semicon, etc., which are coming into this country. So we are seeing that when our students are exposed to the industry, rather when the students they talk to employers, and employers realize that these students are a different breed of students who understand when they come who are during the course itself, they're able to be real problem solvers and able to, and hopefully they can deliver better at them when they get into the industry. So that's how we are trying to address it, Nana. And I'll pause here as we take this conversation forward.
Very, very interesting, Arun. Very interesting. And I'm also interesting the way you say you're working backwards. Like, you're taking what the industry wants, what are the gaps that happens when somebody, joins an industry for a job, and then working backwards into what you can do in the curriculum and pedagogy, and how do you make sure that they are ready there. This is very, very interesting, very fascinating. I'm going to come back to you about certain questions, but before that, Ravi is looking a little lost there. I'm going to turn to him. Professor also talked about this gender bias. On a lighter note, I heard somebody say that for the solar panels that are there is a maintenance function, and there was a job role for this maintenance function. And one of the things that they said is the solar panels are usually in a certain altitude. And once you go there, you need to handle that and change it and all those things. So one of the requirements was able-bodied men and who can handle that at some point of time. In 3 years, when they looked at the job role, it actually had more patient young women to be part of the job role. What changed was there were robots who were changing that. And what needed now as a skill set was somebody who can program the robots better, not who can physically change it. So I understand, the gender biases are being broken. My question to you is, in your industry and beyond, where do you see career progression for people who join manufacturing? It is very interesting. And today we see a great opportunity and a requirement for engineers to happen. And we discussed about what is required. So I thought I'll kind of, seek your views on not just the skill sets that are required, but what could be the career prospects? What do you see as prospects for people who are choosing manufacturing as their career? Ravi?
Nana, this is specifically for women that you want to address this question?
No. In general, I just said for both men and women. In our audience, we have a lot of women, girls who are part of this. So engineers are no more this typical men. So for both, I mean, not anything specific only for women.
I mean, to start with, of course, Schneider has a very strong commitment to gender balance. So we are among the leaders, that balance. And in fact, we strongly promote women in energy and in manufacturing. The realm is changing. And I think that even with this audience, we encourage more and more women to come into energy and smart manufacturing for sure. Now, typically, the kind of job roles, I mean, of course, historically, I think Krishnan really speak about the different type of job roles that were available in in the manufacturing. And I in the beginning of my address, I speak about the type of job roles that we are looking at today. And I will probably, kind of repeat it for you. Typically, if you look, data scientists, it's an important role, because today the entire industry 4.0 is all about generating data and making sense of the data for predictive maintenance, for creating dashboards, reports, IoT engineers. So, we are all talking about Internet of Things. The moment you are talking of collecting data from sensors and then, doing analytics around this data, it's all about understanding how, we are collecting data through these sensors. So the entire IoT space and the kind of job roles that come out from this experiential learning. Of course, smart factory managers, because all the processes are moving towards an IT/OT integration phase. So this shift needs to be managed by smart factory managers. These are new roles and responsibilities that are coming in the smart manufacturing space. Robotics, of course, is one more key area, and there are robotic engineers and technicians that are really required for us. Smart factory supervisors, smart QA managers. Now, in front of everything now, even the conventional roles, QA was a conventional role. Now you add smart in front of it, becomes a new role. And it is true. The type of jobs that QA was doing in the past is maybe replaced by artificial intelligence. But then there is a role that is coming new because of everything becoming finally smart. It's a smart QA manager. So I think that and I think Arun placed it very well. It's the lack of knowledge, not only skill, and I fully agree with him that he's right, that there needs to be an awareness for students of the change that is happening. And while there is a lot of roles that are replaced by AI, there is a lot of new roles that is getting generated. And I think the whole idea of experiential learning and then moving to, making by yourself and being more imaginative with the kind of application that you have learned gives you this type of understanding of new roles that are coming up in the smart manufacturing space. And since the whole space is becoming digital, cybersecurity, OT cybersecurity, I spoke in the beginning, it's an important role. Sustainability specialist, energy analyst. So these are typically very strong new roles that are coming into this space of smart manufacturing. Of course, I don't repeat the conventional roles. It was spoken by Krishnan, and it's very well known in the smart manufacturing space. Yeah.
Oh, lovely. So, Rajiv, what I take is there are so many new roles that are coming in, and they are all intense roles. And the typical view one has of who gets into manufacturing is completely demolished. Like, we are looking at very exciting roles. In fact, at some point of time, when I was younger, this BPO seems to be a very attractive one where everybody wanted to, go there because they thought the job role was very nice. And from what you say, the usually so-called hard manufacturing role seems to be such an interesting, exciting, forward-looking roles that you're saying. So it's very nice to hear that. And also the future prospects. From what you list, there are so many roles that people can grow vertically and horizontally in manufacturing. I wish I was much younger. But thank you so much for sharing your thoughts.
I think, Nana, just to give you an example, even the logistic part of moving materials into the manufacturing, because a lot of people have this reminiscence of working in a manufacturing, which is very dirty, difficult, or sometimes dangerous environments. This shifting, today, if you look from a typical warehouse perspective, where you are moving raw material into your manufacturing plant for manufacturing, is also done by mobility robots. And you required robotics engineers, which then are programming those robots, making it more efficient to be able to. So I think that the entire downstream and upstream of manufacturing process is changing significantly. There is a lot of integration of, new technologies, and especially digital technologies that are coming. So it's very exciting. And I feel that there would very soon this whole adoption of Industry 4.0 penetrate very strongly. Today, it is maybe spoken at, only with the large industries and not so much with small scale, medium scale industries. But this integration is going to happen. There's no other way. If India were to become a strong manufacturing country, and It is not that only with the top few manufacturing large industries, we will be able to. It has the integration, the adoption has to go down. It has to percolate even to our small medium scale industries to happen.
MSMEs,
And
as they
when
call, yeah.
and when this happens, these will be typically sought roles for students. So I guess that our students and youth should invest, in training themselves into these careers.
Wonderful, sir. Thank you so much. Thanks. Professor, very quickly, we talked about pedagogical changes. With all these far-reaching changes happening, do you think there should be some changes in the pedagogy, or already people are talking about pedagogy and things like that? And what are your views on, very quickly, on some pedagogical changes that you think educational institutions should bring about?
So my opinion is slightly orthogonal to what some of the people may want to think. See, I think industry wants people who are problem solvers. And the question is, how do you make engineering students problem solvers? So you have to challenge them. You have to give them problems to solve, show them how to solve problems, ensure that they solve the problem in a very systemic way. And only then you would be able to get trained and educated bachelors of engineering students who actually exhibit analytic skills more than, say, what I would call absorption skill sets. It's like, when you play cricket, today the way the education system is that it is like, say, I watch cricket in TV and suddenly I become a great batsman. Okay. I don't even go to the net, leave alone play matches.
Even Sachin Tendulkar can't do that.
Yes, exactly. So that is the exact modality that we need to change. While it is important for them to understand how things work, it is even more important to make things work. They need to get to an ability where they make things work. I mean, if you go to the classic and Google Wikipedia on the classic definition or a difference between an engineer and a scientist, you know very well the classic cliche is engineers solve a problem, yes, while scientists probably create the problem. On a lighter note, of course. Okay, no, I'm half engineer, half scientist. Yeah. So I think we need to relook at how we develop the capabilities and the mindset of young engineering students. Okay. And I think I also probably subscribe to the fact that this needs to start even earlier in the schools. But even if that doesn't happen, I think you have a great opportunity if you change the way engineering happens, is taught. I think you can change it at least at the bachelor's curriculum. Now, I think, Arun was talking about NAMTECH and how NAMTECH is trying to change it at least at the post, bachelor's level. So I think at least that's a great start. And slowly these kinds of, mindset change has to percolate down so that we get very problem solvers rather than, guys who know how things work. But make things work is more important. Thank you.
Absolutely, absolutely, Professor. Thank you so much for sharing your thoughts. And this is indeed quite an eye-opener. Arun, very quickly, manufacturing seems to be very exciting. And like I said, I wish I was younger and start the career all over again. Manufacturing seems to be one of those sectors where I would really bet on. But see, the manufacturing, while we put it in as an overall thing, there is electronics manufacturing, and within that, there is mobile, there is telecom, there is network, there is healthcare. Other than that, there's pharma, automobiles, of course, specialty steels, energy, defense, and it goes on. It is not as small as we think. It is such a widespread one. And one thing that is coming across from all the three of you gentlemen saying is innovation and something that people can bring in original thinking and solving. This is not easy at all. And I just wanted to quickly get your views on how is NAMTECH trying to address this? The multitude width at one level and depth and making people think originally at another level. How do you make this magic happen?
So if you take any factory, you take any plant or any manufacturing sector, I think broadly three areas are emerging. One is, of course, the common thing is every one of those, whether it's pharma, auto, steel, semicon, everyone is transitioning to what is called as a smart manufacturing environment, and I'll speak about it. The second is the this product specific thing. And what is happening on that side is every one of this industry wants to accelerate product development. And the third is, which is happening across industry and specifically say some like auto, etc. more, is the electrification piece of it. So therefore, these are, while something like smart manufacturing is common across industries, accelerated product development is also common. Electrification is another big theme in industry. So we pick up these themes. We look at it from the industry side of the story. And if you look at, say, any industry, these are the 3 or 4 areas they want the, like Professor said, problem solvers in. How do you make the manufacturing smart? How do we accelerate product development? And how do we bring about new changes like electrification, etc. in their sectors? Common to all this is on the IT side, there is so much of common. It's common, 3 levels again. Every industry wants to first automate. Every industry post automation wants to connect, which is connecting, networking, etc. And every industry post that wants to make it intelligent. That is bring in data and everything. So you see, these are cross-sectoral themes. So our student, when we look at it, the first half of the year, the first half of the curriculum is looking at those commonalities and what we call as the principles of smart manufacturing. So we bring in those elements. And then the next section or the next half of the year is about bringing the specific sector, say auto, say smart, say semicon, etc. But then this 1 year is actually a year which is more like an exploratory experiential year. We say the learning does not end here. We say that we have introduced you to the principles of smart manufacturing. We have introduced you to certain specific areas. Now it's up to you to explore the world of manufacturing. And believe us, it would be an exciting world if you do in that fashion. And therefore, this is also, in a sense, pushing people to look at lifelong learning in manufacturing careers, etc. And that's the whole idea of an institution like NAMTECH, which sees itself as a partner in a student's journey as he or she navigates their manufacturing careers.
Lovely, Arun. I think in many ways, the consultant in you is still very much alive. The formulas that you gave, the 5 gaps that you said, just to recollect, is worth mentioning again. The awareness gap, the knowledge gap, the skill gap, the attitude gap, and last but not the least, the imagination gap. But more importantly, I'm fascinated by what you said about what NAMTECH does for this. 3 again, automation and all about automation across industries, connectivity and network, which seems to play this big role of why Industry 4.0 even happened. Last but not the least is the intelligence part. How do we bring in the innovation, the intelligence, finding more about this, making it really, really exciting. And as you rightly said, the learning just starts here at NAMTECH and it's not as if you end there. You just kindle, you create learners rather than teach everything in that sense. Like that's very, very well said. I mean, I know we are on the top of the hour, and I think what I take away from this, more like, a sum of what I learned, is there is a paradigm shift that is happening in manufacturing as a sector. Paradigm shift in whichever way we look at it, in job roles, in definition of job roles, in the capabilities and skill sets that are required, in the profiles of people who want there and their expectation on what happens there, in the learning environment, and what kind of things that one should learn, in the imagination that is required for manufacturing. Earlier, it was supposed to be, you even call it shop floor, right? As if something happens very mechanically. All of the speakers said that it is not so. It is a great place for imagination and learning. And last but not the least, Ravi also mentioned how career paths for those who choose manufacturing is literally left to one's imagination to see how much and how far they can go. Wonderful, exciting. Thank you, gentlemen, for sharing your thoughts. I'm sure our young listeners and not so young listeners like me found really, really useful these conversations, and we will apply it wherever possible and hope it was useful for the students to plan their careers. Rajiv, back to you.
Thank you so much, Nana. And it was a wonderful discussion. at least for me, it truly stimulated my brain. So much is happening and so much to learn. We will now open up the floor for the Q&A session. I will request the participants to click on the Q&A button and key in their query, which can then be addressed by our panelist.
Engineers are initially a bit shy.
Always.
Yeah, you need to catalyze with a question, and then you can't stop the questions. That's usually how it works.
One suggestion is you can also put it in the chat box in case you guys are not already doing. You need not even speak up. Okay, wonderful. As you are preparing your questions and as you are putting it, like Arun said, it doesn't stop with this webinar. We are here to answer your questions as you go and as and when you get some.
There's already a question on the chat box.
On the chat box? Okay.
Yeah,
good question.
So the question is, could you describe more about sustainability sector and the job roles relevant to it?
Sure. Can I take it?
Yep.
I mean, you could please help me with this. First of all, on sustainability, there are two broad areas we look at. One is energy transition, and the other is the circularity of materials and things like that. These are both these things across sectors, whether it is manufacturing, whether it is building construction, whether it is mobility. And within energy transition, since you spoke about, you're asking about job roles, we are talking of 4 or 5 transitions. We are talking of transitioning from say a non-renewable kind of energy source to renewable one, which is the whole transition from say thermal to electric. So a whole load of job roles emerging in the areas called smart grid and all those kind of things. The second smart grid related job roles. The second transition is the transition which is happening in fuels, where we are talking of we are moving from fossil fuels to various other kinds of fuels, whether it's green hydrogen or various other things. Again, job roles in that sector are picking up. The third transition is the transition in the building sector, where we are talking, it's all about energy efficiency. So the whole transition is how do we make smart buildings, smart campuses, smart cities. So a whole load of job roles on that. Similarly, smart factory in manufacturing sector, we can speak. So you look at every job role, how do we bring in sustainability, energy efficiency elements into it? And lastly, of course, this whole drive of transitioning everything to electric demand side, many things moving to electricity, use of electricity, like in the case electric vehicles, etc. So that's a whole lot of job roles coming in. So essentially the transition, energy transition is creating a lot of job roles, changes in this sector, a lot of transitions and changes, and thereby a lot of job roles. I think it is one of the most exciting areas going forward. And right now, maybe the count of job roles is low, but believe us, in next 2-3 years, you will see, I mean, a whole lot of job roles emerging in this sector. Over to you, Nana.
Yeah, so I just wanted to add something like, beyond that physical or environmental factor that Arun just mentioned, which is largely happening in energy and related areas. I see a transition in every single job role that is happening. You must have heard the term called ESG, environmental social governance norms, wherein you see an inclusion that is happening on a social level. And the governance norms, what do you bring in? So I would see an impact that is happening almost in every job role. In some of the roles that Arun just mentioned more significantly, but going forward, and ESG and related areas and your application of that is going to be important for any future job role that you take up. Gauri Butler.
We have one more question. What roles are presently available for mechanical engineer students in energy sector?
Wow, that is tailor-made for Arun.
Arun, Ravi, either of you could respond.
Ravi, you could come in. Yeah.
Yeah.
I think Ravi spoke about this. You are no longer a mechanical engineer you are a more a multidisciplinary engineer. Yeah, go ahead, Ravi.
Yeah, so I think that uh, the way Arun explained the job roles in sustainability, normally I would have addressed this type of topic sitting across an academic institution. But the way that you addressed is the new shift that is happening. An academic institution, if it is able to outline the kind of job roles required for the industry for a specific sector, and if does it perfectly, it's the change that we need. Today, if you talk to an academic institutions to be able to say the new roles in sustainability, I'm sure that most of them are not able to address. So thank you. I think that's the way that we expect academic institutions to be able to move ahead in this country, is to really talk the same language of the industry. And it's possible if the academic and industry works really together. Now, coming to, I think, quickly to the question. So of course, historically, for any energy industry, electricity industry, of course, your skill set in mechatronics, I think, is where historically you would have known the kind of job roles that may be existing for mechanical students. Mechatronics, when I say, is you are combining mechanical and electronics capability. And herein, you are talking about understanding the jobs in motor starters, drives, hydraulic, pneumatic, and then combining it together to work in a process line, and of course combining it to the different types of sensors, etc., that might be available. So these are historical job roles for mechanical. Now, what makes it more and more interesting for mechanical students is you as a mechanical engineer should now also engage into understanding IoT capabilities to really see, how the sensor integrates to collect data, and then how you make sense of that data into analysis, analytics. So then your job roles are in the energy sector, moving into building management systems, wherein you are, of course, historically understanding how an AHU will work, a refrigeration would work, all, your fundamental understanding of mechanical. And then you are then looking into the application of an entire building, integrating it to the full understanding of integrated building. I'm sorry, if some of these terminologies are not something that you are aware of, you can always go back and search on Google, and you will find these terminologies very easily to help you understand the kind of roles that I'm really talking about. And likewise, when you come back, so I think that the fundamental point, and that is something that we have been really stressing across in all the conversation today, is to go back and improve your skills on digital, and the combination of the digital skills to your areas, whether you are electrical, how it connects with your hardware. If you are mechanical, how it connects to your hardware. I think that's the fundamental place where you should be really looking at. And I feel Arun also in the beginning outlined the principle very clearly. We spoke about connected products. So it was the era of automation. It's finished. I mean, it's not finished, but let's say it's something that we assume that, yes, it's in the past. Then came connected products. Then on connected products, we are talking about edge control. And then in above edge control, we are really talking about applications and analytics. So these are the three areas in extension to whichever area that you are coming from, whether you are electrical or mechanical. Focus on how to enhance your skills in those areas.
You want me to give a slightly different angle to this? So,
Sure.
I mean, just broadly, for this question, because there are no other questions appearing yet. So, see, if you look at energy, you look at it from at least three major perspectives. One is, how do you harness energy, which means how do you create energy, right? So whether you create energy from nuclear, whether you create energy from wind, whether you create energy from coal or oil, every step of the way, mechanical engineers play a very key role. Now, today's definition of what a mechanical engineer does in these has changed significantly. Today, you are do a lot more sitting in front of a computer or remotely controlling what's going on, and find out what is the best decision making, decision that you have to make when something happens while you're doing this. So this is the first, broadly speaking, energy sector. How do you get energy? The second is, how do you use energy? Okay. So wherein you're talking in terms of, say, whether you're going to store it in a battery, whether you're going to, burn it and, in a car IC engine, or whether you're going to have a jet engine propulsion type of things. Okay, every single way, or how do you transport? You take a coal, you take oil. How do you transport from one place to another place? Right? Do I do it in trucks? Do I do it in a pipeline? Okay. How many of you know that there are pipes going all the way from Ahmedabad to Cochin? Do you know that there are pipes going from Allahabad to a port in Orissa? Today we have close to 1 lakh kilometers of underground pipelines that are transporting oil, gas, and coal. Now, where does the mechanical engineer come? Mechanical engineering student is going to look at how do you do it better? How do you make sure that nothing leaks? How do you make sure that the material that I'm using is manufactured in the best possible way? Finally, the third part of energy is what do you do with after you do everything? You take coal, you burn the coal. What do you do with what's left behind? Okay, so there is always a process where you want to optimize to make sure that the waste that you create is minimized. Okay, and how you go about it. I give you another example. Right now, I am talking to several battery manufacturers, and I kept saying, let me talk about the battery cell. These are auto companies. They, many of your EVs are all auto companies, right? They all use batteries. I thought that the most important problem they're having is how do you make the battery better? What I'm finding is the biggest problem they are having today is not the battery, but it's a thermal problem. The heat that is generated from the battery should be contained and cooled in some better way, where mechanical engineers have to figure out how to cool it without increasing the weight of the vehicle. This is a super mechanical problem today. If any of you know how to do it well, I can give you like 20 job that nobody can match the salary. Okay, Tesla will take you in no time. Okay, so that is the thing. So mechanical engineers have versatility that is unbelievable, right? So that's basically where I would say that energy sector offers incredible opportunities for mechanical engineers.
Professor, maybe you should also give your email ID. There will be applications that will start going in.
Yeah, thank you. Yeah, absolutely. I'll put my email ID in chat for sure. Okay, in a minute.
We have one more question, and let me read that through. How do you envision the future of manufacturing with the full implementation of Industry 4.0 technologies? And what role can students and new professionals play in this transformation?
Okay.
Professor, you want to go?
Implementation of Industry 4.0 technologies. What role can students and new more the young ones, that's the question.
So I think they are going to drive it. They are the ones who are going to drive it.
Exactly. I mean, the future is certainly unpredictable. In fact, today people are now gone beyond 4.0, and people are now talking about Industry 5.0 today. Okay. Now I still don't understand what 5.0 is, but 4.0 is not something that's new. 4.0 has emerged maybe 10, 15 years ago and slowly transitioned itself into the industry. Today, industry wants to create opportunities for us to understand the process through data. Now, to get data, you need sensors, you need communication protocols, you need how to understand the data. So data analytics comes to the picture, right? Now, once you understand the data, the next thing is, what do I do with the data? What does data mean to me? So for instance, if I'm a manufacturing, let's say for some reason I'm manufacturing bread. Okay, you're manufacturing bread. Okay, you must understand what is the right temperature inside the oven that will give you the best bread that is not brown on one side and white on the other side. It should be uniformly brown. If I were to say, do you know how a bread is tested? It's not new. This is about 30 years ago. One of the biggest problem was the bread manufacturing company in US came to us and asked us, how do you know when the bread is done right? In fact, very interestingly, I looked and thought about how does my mother know the idli is well cooked? You know what she does? She takes a little, like a fork, and she pricks it and then sees whether anything is stuck to the thing, fork. And if nothing is stuck, then she says it's well done. All right. So we said, I can't prick a bread. So what do I do? So all we did was we created an air jet. Okay. So we pushed the air jet will sort of like push the bread. Okay. And we watch how fast it comes back. And we found that very nicely you can tell that the bread is well cooked. Okay. This is not new. This is 30 years ago. Okay. And it was actually implemented. The magic is it was implemented. Right. So how do we,
Wow.
you have to also find out
Talk
how do
about
you
innovation.
correct, how do you correct what you're doing? Okay, so that's the next part of it. Again, here, what we talk about is all the physics that you learn, the mechanical engineering or the engineering that you learn of the cause and the effect will come into picture. Today, we are talking of physics-based digital twin models, right? That we understand. I can say, okay, if I increase the temperature on this side by 10 degrees, what will happen to the bread? Will it get cooked faster? Will it get cooked slower? Or will one side become brown, one side become white? And how long will it take? So all this is physics-based. So first of all, you need to know all the sensors and IoT and everything. But again, here digital twin is playing a big role. Digital and it is physics-based. It is mechanical engineering based. It is heat transfer based. It is chemical engineering based. It's electrical engineering based. All the things coming together to create a virtual twin of a physical process, right? So everywhere along the way, Industry 4.0 is going to change. Tomorrow, I don't have to really figure out, well, if something I see on the plant or something I measure, I will not be able to have the time to react to it. My mind will no more be there. My mind will have been transferred into an algorithm, okay, in a chip, which will be thinking while it is measuring and will say, okay, this is what you are to do. And that is where the AI comes into picture, right?
And
so you will have thinking machines. Yeah, and then the professionals are going to put the algorithm that will make them think, okay? Make the chip think. So actually going back to what Ravi said, we have to reskill ourselves, okay? When computers came, many people thought, oh my God, everybody is going to lose their jobs. Guess what happened? Okay.
More jobs came.
Yeah, more jobs came. Higher paying jobs came. Today, a lot of automation is killing a lot of jobs, like like the what do you call it? The call centers and all that. All right. Trust me, all these guys will become AI programmers. Okay, or they become annotators. All right. And guess what? What used to get them 100 rupees an hour, today they can charge 300 rupees an hour. Right. So every time technology has made a difference in the way we live, man and women, I'm sorry, humans have always found a way to leverage that to upskill themselves and make themselves more valuable.
And Professor, if you notice, the younger professionals, the ones who are entering, have a better propensity to think of new things rather than those who have been through the system. So to answer Bharat Bhushan, I think if you are a new professional you are entering, you should be bubbling with innovation, the works that Professor Krishnan just mentioned. Not everybody who has the experience of Professor Krishnan can be innovative like he is, right? Usually the youngsters are the ones who come up with more ideas. So I think there is a lot of opportunities for the young professionals and the students to innovate and hence make a big difference.
So in the interest of time, I'll take up two questions at the end. Both of them are interrelated. The first one is about the future, which I think Ravi has already answered to a certain extent. Because of Industry 4.0, the impact on the job market, what kind of new roles will emerge. And the second question is about the innovation and trends that's associated with Industry 4.0 over the next 5 to 10 years.
Okay. So I'll just start and then I'll request quickly the panelists to answer this. We saw, I mean, when I was speaking also, I talked about the new job roles that are emerging, right? Some of these job roles which we had even thought of before, like, autonomous remote plant operators, predictive supply network analyst, then design for additive manufacturing engineers. And so these are even on a lighter one, like, social media engineer, matchmakers. A lot of new job roles that are coming because they are backed by technology in manufacturing and other industries. So I see a lot of change that are also sometimes fundamentally different that are emerging because of the opportunities that technology throws in, right? Any quick thoughts on the manufacturing side, Ravi, that you think, there's going to be a big change in the way jobs are looked at, or new job roles that are emerging?
Yeah, I think that we've spoken quite a bit in terms of the new job roles that are coming. I think one of the questions was in terms of the trends, and if you look at the global trends around us, there are top 3 trends that we identify as a company and as an industry in electricity, industrial automation, which is urbanization, digitization, industrialization. These are the top 3 trends, and everything, all technologies for us is moving to address. More and more people are going to come and live in cities. Cities will require to become more smarter to be able to address the demand that will come in the space of energy, electricity, etc. So there is a strong um, movement towards everything in city becoming more smarter, whether it be water, waste management, electricity, public services. So I think that there would be ample amount of opportunities. These are not new, technologies or needs. These are existing needs and technologies, just that it will become more smarter. There will be the whole adoption of digital that will come into this space. Similarly, for industrialization, and I think this is where we speak all about in smart manufacturing, I feel that, like I said, that especially, for India, it is at this cusp where we have a lot of young people. I think that for any country, the biggest strength is its people, right? And it's the right time for us to be investing into our people, giving them the right skills. It is not possible, for us to becoming a manufacturing power in the world without investing and giving our people the right skills. So I feel that at Industry 4.0, of course, opens a lot of doors with the whole IT/OT integration that is happening. And this will open up a lot of job roles. Specifically, we've named this, I guess that if you rewind this webinar and listen to it, these are job roles that we already see, and there will be new that will be coming as this demography and the manufacturing space changes very, very rapidly. Yeah, but fundamentally, I think digitization, these skills on decarbonization, energy efficiency, these are specifically the kind of roles that will be taking space for, and students need to be investing their career and their learning on this.
I think each one of us needs to aspire to be a T-shaped kind of person, where the length or the top of the T is the breadth of these common technologies, AI, ML, name those technologies which help, and the depth is the operating technology which Ravi is speaking of. So you have to have the depth in your own sector, whether you're mechanical, electrical, but you have to have the breadth in terms of the emerging technologies. Put together, I think you will be a valuable asset to any company you join, and your career would also grow accordingly. And over years, you need to make the T bigger and bigger. That's how I see it.
Wonderful. That's very well said. I know we have overshot the time that we had requested from all of you by many minutes, but it is very heartening to say that see that entire audience are still wanting to listen more. Rajiv, I leave it to you.
I think there are a couple of people in our audience who will try and answer over here itself. We will reach out to these students to answer their queries, especially which is related to admissions or the softwares that they would like to know about. There's another query about a student from the COVID batch. And unfortunately, many students in the country went through that wherein they did not get the skills. So yes, we can help you with that, and somebody from our team will definitely reach out to you for it. So with that, I'll probably thank everyone and close the session today. We will drop a note to all the participants and share our email ID so that we can assist you in your journey going on. Thank you so much.